Hey there, science fans! Today we're talking about something super important, transporting chemicals safely. You see, moving powerful chemicals like sodium cyanide or sulfuric acid is a bit like transporting a tiger. You need the right container. We're talking about pipelines. These aren't your ordinary water pipes. These pipelines carry materials that can be corrosive, toxic, or even explosive. That's why choosing the right material for these pipelines is crucial. Think about it. A leaky pipe carrying something like hydrochloric acid could be disastrous. We're talking about potential harm to people, animals, and the environment. Nobody wants that. So how do we make sure the chemicals get where they need to go without any mishaps? By understanding the properties of both the chemicals and the materials used for the pipelines, that's how. First up, let's talk about sodium cyanide. This chemical is used in mining and other industries, but it's also incredibly toxic. We're talking serious danger here. So, what kind of pipeline can handle this tricky customer? Steel is a no-go. Sodium cyanide can corrode steel, leading to leaks and spills. Not good. Instead, we turn to more resistant materials. Special plastics, like high-density polyethylene, HDPE, are much better choices. They resist corrosion from sodium cyanide and can handle the pressure. But remember, even with the right material, regular inspections and maintenance are key. We can't be too careful when it comes to safety. Next, we've got sulfuric acid, a real powerhouse in the chemical world. It's used to make fertilizers, batteries, and even explosives. But handle it wrong, and it'll eat through metal like it's nothing. Ordinary steel pipes? Forget about it. They'll dissolve faster than a sugar cube in hot coffee. For sulfuric acid, we need something tougher, much tougher. Enter exotic metals. Think titanium or alloys like hastelloy. These materials laugh in the face of sulfuric acid's corrosive powers. Of course, these materials come with a hefty price tag, but when it comes to safety and preventing a major chemical disaster, it's a small price to pay, wouldn't you say? Now let's talk about hydrochloric acid. It's used in swimming pools, to clean metals, and even in your stomach. But don't let that fool you. Concentrated hydrochloric acid is powerful stuff. Just like with sulfuric acid, regular steel pipes are out of the question. We need something that can withstand hydrochloric acid's corrosive nature. The good news is we have options. Certain types of plastic, like polyvinyl chloride, PVC, and chlorinated polyvinyl chloride, CPVC, are up to the task. They resist hydrochloric acid's corrosive effects and are much more affordable than exotic metals. Hold on to your goggles, because next up is sodium hydroxide, also known as caustic soda. This base is used in everything from soap to drain cleaner. It's also highly corrosive, especially at high temperatures. For sodium hydroxide, we have to consider not only corrosion resistance but also temperature limitations. Some plastics like HDPE might be fine at lower temperatures but become vulnerable at higher temperatures. In cases like this, steel might be an option, but it needs a little help. We're talking about special linings. Rubber or PTFE, Teflon linings can protect the steel from sodium hydroxide's corrosive effects. Finally, let's look at ammonium sulfate, a common fertilizer ingredient. Now, compared to the other chemicals we've talked about, ammonium sulfate is relatively tame, but don't let its gentle nature fool you. It can still cause problems if we're not careful. Steel pipes can be corroded by ammonium sulfate solutions, especially at elevated temperatures, or if impurities are present. So what's the solution? Again, plastics like HDPE and PVC often come to the rescue. They offer excellent resistance to ammonium sulfate corrosion and provide a cost-effective solution for transport. Now, even with the best materials and careful planning, accidents can happen. That's why learning from past pipeline failures is essential. Remember the 2010 Kalamazoo River oil spill? A pipeline carrying heavy crude oil ruptured, releasing millions of gallons of oil into the river. It was an environmental catastrophe. This disaster, among others, highlighted the importance of regular pipeline inspections, proper maintenance, and using the most appropriate materials for the job. You see, choosing the right pipeline material isn't just about saving money. It's about protecting lives, our communities, and the environment. The science of materials is constantly evolving, and that's good news for pipeline safety. Researchers are developing new materials and coatings that are even more resistant to corrosion, stronger, and more durable than ever before. Imagine self-healing pipelines that can repair minor leaks automatically, or pipelines equipped with sensors that can detect potential problems before they even occur. With these advancements in material science, we can look forward to a future where transporting even the most hazardous chemicals is safer and more efficient than ever. And that's something we can all feel good about. So the next time you see a pipeline, remember, it's not just a pipe. It's a carefully engineered system designed to transport vital chemicals safely and responsibly. And that's science at its best.